Okay, now we'll start with derivatives first principle part 2. In part 1 we saw algebraic first principle. Now we'll see trigo, exponential and logarithmic first principle. So this is going to be second chapter, first principle. Again we are continuing with first principle. The formulas that we use for this, the first principle part 1 remains the same. So you will have all the formulas that are used for first principle. All these 1, 2, 3, 4, 5, 6, all these 6 formulas remain as it is. Okay. The question that you will get will also be the same. It will still be differentiate the following functions using first principle. Now let's see a sum. Suppose if I had cos x, cos 5x. Okay. Let's see how do we do this sum. You will say let, same method that you used in the first part, let f of x be equal to cos 5x. Therefore f of x plus h is going to be cos 5x plus h. F of x plus h minus f of x is going to be cos 5x plus h minus cos 5x. Cos minus cos, you will be using the factorization formula. Cos minus cos is minus 2 sin sine. So this is going to be minus 2 sin 5x plus h c plus d upon 2 sin 5x plus h minus 5x upon 2. Right? So this can be written as minus 2 sin 10x plus 5h upon 2 sin, this is going to be 5x plus 5x minus 5x will get cancelled, so you will have 5h upon 2. Once you get this, you can apply first principle. So I can say by first principle, f bar of x is limit of h tends to 0, f of x plus h minus f of x upon h. This is nothing but limit of h tends to 0. F of x plus h minus f of x we found out is minus 2 sin 10x plus 5h upon 2 sin 5h upon 2 divided by h, this h, right? Divide by 2, multiply by 2. This 2 and this 2 gets cancelled. Now this is going to become minus sin 10x, substitute the value of h as 0, plus 0 divided by 2 sin. You will have to multiply by 5 also, because this is 5h by 2. This is 2 you had already multiplied. This is 5, multiply by 5, divide by 5. Right? So this is 5h by 2 upon 5h by 2. Sin theta upon theta is 1 upon 5. This 2 and this 2 is gone, so this 1 upon 5 remains as it is. Denominator of denominator becomes numerator, so this is minus 5 sin 5x. So your answer is going to be minus sin 5 sin x. Okay. Next, let's move on to the next sum, guys. Sin square x. Let f of x be equal to sin square x. Therefore, I can say f of x plus h is sin square x plus h. Right? Now, f of x plus h minus f of x is sin square x plus h minus sin square x. This is in the form a square minus b square. A square minus b square is nothing but a plus b into a minus b. A plus b, a minus b. Let this term be as it is. This can be written as sine x plus h plus sine x. Now, sine minus sine is nothing but 2 cos sine. So this will be 2 cos, factorization formula, x plus x by 2 sine x plus h minus x by 2. Right? This can be written as sine x plus h plus sine x. This can be written as 2 cos 2x plus h by 2 sine h by 2. Once you get this, then you can apply first principle. If I apply first principle, I can say by first principle, you can say f bar of x is limit of h tends to 0, f of x plus h minus f of x upon h. Right? This can be written as limit of h tends to 0. F of x plus h minus f of x we found out is this, which is nothing but sine x plus h plus sine x into 2 cos 2x plus h by 2 sine h by 2 upon h. Now, we have this multiplication sign here, so I can write the h with only one term. So I already have this h, divide by 2, multiply by 2. This 2 and this 2 gets cancelled. Sine h by 2 upon h by 2 is 1, so I can use the formula here. So this is going to be sine, this is sine x plus sine x, and this is going to be cos x, because h is 0, 2x upon 2 will give you cos x into 1. So sin x plus sin x is 2 sin x cos x. Using multiples, 2 sin x cos x is nothing but sin 2x. So the answer for this will be sin 2x. Fine, do we get this in here? Let's move on to the next one, guys. X square sin x. Right? Let's see how do we do this sum. We will say let f of x be equal to x square sin x. Therefore, f of x plus h will be nothing but x plus h the whole square sin x plus h. This can be written as, this can be expanded as a plus b the whole square, so a square plus 2ab plus b square into sin x plus h. Open the brackets and simplify. X square sin x plus h plus 2xh sin x plus h plus h square sin x plus h. What am I doing? I am multiplying all the three terms with sin x plus h. The expansion I am multiplying with sin x plus h. Fine. Now, this can be written as x square sin x plus h plus, between these two terms I could take h common, sin x plus h common, in which case 2x will remain from here and h will remain from here. So your answer here will be x square sin x plus h plus 2x plus h into h sin x plus h. That's your value of f of x plus h. Now once you have the value of f of x plus h, the next thing that you have to do is find out f of x plus h minus f of x. This is nothing but x square sin x plus h plus 2x plus h sin x plus h, that's my f of x plus h, minus x square sin x. Now between the first term and the last term I can take x square common, in which case you will have sine x plus h minus sine x plus h, 2x plus h sine x plus h. Between the first term and the last term I have taken x square common. Now this can be written as x square as it is. Sine minus sine, factorization formula, sine minus sine is 2 cos sine x plus h plus x by 2 sine x plus h minus x by 2 plus h, 2x plus h sine x plus h. Right? Now this can be written as x square 2 cos 2x plus h by 2 sine h by 2 plus h, 2x plus h sine x plus h. Once you have this, now you can apply first principle. I can say by first principle f bar of x is limit of h tends to 0, f of x plus h minus f of x upon h. We just found out the value of f of x plus h minus f of x. F of x plus h minus f of x is nothing but x square into 2 cos 2x plus h by 2 sine h by 2 plus h, 2x plus h sine x plus h. That's my value of f of x plus h minus f of x upon h. Split the numerator, so this will be limit of h tends to 0, x square 2 cos 2x plus h by 2 sine h by 2 upon h plus h, 2x plus h sine x plus h upon h. Divide by 2, multiply by 2. Why did I do that? So that the angle in the numerator and the number in the denominator is same. This 2 and this 2 gets cancelled. So this is going to become x square cos h becomes 0, 2x upon 2 is cos x, sin theta upon theta is 1 plus h and h gets cancelled. So this is going to be 2x plus 0 sin x plus 0. So this is going to be x square cos x plus 2x sin x. That will be your answer. Fine, do we understand this? Nice sum. Let's move on to the next sum, guys. Log x to the base a. Let's see how do we do this. You will say let f of x be log x to the base a. Therefore I can say f of x plus h is log x plus h to the base a. F of x plus h minus f of x is log x plus h to the base a minus log x to the base a. Log a minus log b is nothing but log a upon b. So this is going to be log x plus h upon x to the base a. This can be written as split the numerator. So x upon x will give you 1, h upon x to the base a. Use the change of base rule. What is the change of base rule? It's used in logarithm. Log m to the base n is nothing but log m to the base a upon log n to the base a. This is called as the change of base rule. Fine. Wait, I'll show you this once again, people. This I will write it with another marker here so that you know this well. This can be written as change of base rule. Log m to the base n is log m to the base a upon log n to the base a. Fine, do we get this thing here? Now, this can be written, if I use the change of base rule here, this can be written as log 1 plus h upon x to the base e upon log a to the base e. Now, when we are doing maths, generally we never write the base e. So, whether I write the base e or no, it does not make a difference. Okay. Now, use the first principle. I can say by first principle, f bar of x is limit of h tends to 0, f of x plus h minus f of x upon h. This is nothing but limit of h tends to 0. F of x plus h minus f of x we found out as log 1 plus h upon x upon log a. I'm not writing the base e because I told you in maths we don't write the base e. Whether you write or you don't write, it is implied. It is understood that the base is going to be e. This h I'm writing here. Now this can be written as limit of h tends to 0, 1 upon log a as it is, 1 upon h log 1 plus h upon x. Whatever is the number before log goes up in the indice, so you will use the formula n log m is log m raised to n. So this is limit of h tends to 0, 1 upon log a log 1 plus h upon x raised to 1 upon h. Next, this can be written as limit of h tends to 0, 1 upon log a log 1 plus h upon x. Whatever is the number here, I need the reciprocal of this number in the indice. So reciprocal of h upon x is x upon h. Since I have multiplied the indice by h by x, I need to multiply it by its reciprocal so that the equation remains constant, and this 1 upon h as it is. Now this is 1 upon log a log 1 plus x raised to 1 upon x is nothing but e. H and h gets cancelled, 1 upon x. Log m raised to n is n log m, that means 1 upon x will come down, so this is 1 upon log a into 1 upon x log e. But we know the value of log e to be 1, so your answer will be 1 upon x log e. That's how you solve this. Right? Do we understand this? Can we move on to the next sum? Let's see the next sum. Log 3x minus 2. Right? Let's see this. You will say let f of x be equal to log 3x minus 2. Therefore, f of x plus h is log 3x plus h minus 2. F of x plus h minus f of x is log 3x plus h minus 2 minus log 3x minus 2. Now, log a minus log b is nothing but log a upon b. So this is going to be log 3x plus 3h minus 2 upon 3x minus 2. Fine. Do we get this? Now, this can be written as log, rearrange the terms. This can be written as 3x minus 2 plus 3h upon 3x minus 2. Split the numerator. So this is log 3x minus 2 upon 3x minus 2 plus 3h upon 3x minus 2. This and this gets cancelled, so this will be log 1 plus 3h upon 3x minus 2. Now apply first principle. I can say by first principle, f bar of x is limit of h tends to 0, f of x plus h minus f of x upon h. Now this can be written as, substitute the value, limit of h tends to 0, f of x plus h minus f of x can be written as log 1 plus 3h upon 3x minus 2. This 1 upon h here as it is. Now whatever is the number before log goes up in the indice. This can be written as limit of h tends to 0, log 1 plus 3h upon 3x minus 2. Whatever is this number, I need the reciprocal of this number in the indice. So I am going to multiply the indice with 3x minus 2 upon 3h. To keep the equation constant, I will again multiply by the reciprocal outside. That means this will become 3h upon 3x minus 2. This 1 upon h goes up in the indice here. Fine. Now this can be written as log 1 plus x raised to 1 upon x is e. H and h gets cancelled. 3 upon 3x minus 2. Whatever is the number in the indice comes before the log. So 3 upon 3x minus 2 log e. But we know the value of log e by heart as 1. So 3 upon 3x minus 2. That is the answer for that. Fine, do you understand this? Let's move on to the next sum, guys. F of x is equal to x square plus 5x minus 3. Find f bar of 4. Now so far we were finding out f bar of x. Here they have asked you to find out f bar of 4. Now let's see this. F of x is x square plus 5x minus 3. Therefore f of x plus h, whenever there is x, substitute the value of x as x plus h. So this will be x plus h the whole square plus 5x plus h minus 3. This can be written as x square plus 2xh plus h square plus 5x plus 5h minus 3. Now f of x plus h minus f of x is going to be x square plus 2xh plus h square plus 5x plus 5h minus 3 minus this term. So minus x square minus 5x plus 3. X square and x square gets cancelled. 5x and 5x gets cancelled. That leaves me with, okay, minus 3 and plus 3 gets cancelled. That leaves me with these three terms. All the three terms that you have an h in it. I can take h common, so that will give you 2x plus h plus 5. Right? Now apply first principle. So you could say f bar of x is nothing but limit of h tends to 0, f of x plus h minus f of x upon h. This can be written as limit of h tends to 0. We found this as h 2x plus h plus 5 upon h. Cancel. Once I have cancelled, I can substitute the value of h as 0. So this is 2x plus 5. I am substituting h as 0. This is my f bar of x. But they haven't asked me to find out f bar of x. They have asked me to find out f bar of 4. How do I do that? Wherever there is x, substitute the value of x as 4. So 2 into 4 plus 5. This is nothing but 8 plus 5. That is 30. Right? Let's see another sum of this kind, guys. F of x is x plus sine 2x. You have to find f bar of pi by 4. Right? Let's see this. First, let us find out f of x plus h. This is going to be x plus h plus sine 2x plus h. Let's find out f of x plus h minus f of x. This is nothing but x plus h plus sine 2x plus h minus x minus sine 2x. X and x gets cancelled. That leaves you with h. For these two terms, I can use factorization formula, sine minus sine, 2 cos sine. So this is going to be 2 cos 2x plus 2h plus 2x by 2 c plus d by 2 sine 2x plus 2h minus 2x by 2. So this is going to be h plus 2 cos 4x plus 2h by 2 sine 2h by 2. So that's going to give you sine h. Now apply first principle. By first principle, I can say f bar of x is limit of h tends to 0, f of x plus h minus f of x upon h. This is limit of h tends to 0. F of x plus h minus f of x is h plus 2 cos. I could take 2 common here. So in which case I will get 2x plus h sin h upon h. Split the numerator. If I split the numerator, limit of h tends to 0, I will get h upon h plus 2 cos 2x plus h sin h upon h. I am splitting the numerator. H upon h is 1. 2 cos, substitute the value of h as 0. 2 cos 2x. Sin h upon h is 1. So I have got f bar of x as this. But they have asked me to find out f bar of 4. How do I find out f bar of pi by 4? Not 4, pi by 4. I substitute the value of x as pi by 4. So this is 1 plus 2 cos 2 pi by 4. Divide. So pi by 2. Pi by 2 is nothing but 90. Cos 90 is nothing but 0. Answer is 1. This finishes this chapter, first principle. Let's stop here for the day, people.